we're looking at the kinetic energy and potential energy curves of simple harmonic spring system. So basically, we are looking at these guys. So first thing first, let's look at the potential energies equation. So that will be half of mx square, right? So this is to do with potential energy at a random point. So first is equation of potential energy of a spring at a displacement of x, right? Say x is over here. So for me, x is over here now. So these are the extreme positions. So that being the case, this is your u. And then we have equation of kinetic energy of a spring system over here at a displacement of x. So kinetic energy will be equal to half mv square, but we know that v is this big fat expression k by m. So this will be half of m k by m, right? xm square minus x square, actually xm square minus x square. The square and square root and all of that will get cancelled, and you have this. Okay. Now, if I dig into the formula over here, what can we infer? U is proportional to x square. And here, if I dig into it, k is proportional to minus x square, right? This is plus and this is minus. So I have a graph for you guys wherein I am plotting x square and minus x square. So you can see the equations over here, y1, y2. So on plotting, we get this graph. So we have a smiley face for x square. For minus x square, it is a frowny face. So basically, at the extremes, your kinetic energy will be minimum. Okay, so this is 0, while the potential energy will be maximum. At the mean position, the entire potential energy becomes kinetic energy. Okay, sorry, I kind of got distracted a bit over here. So I was talking about at the extreme case. So we have the extreme case of max and left max and the right max. That is the extreme displacement and the mean position. At the mean position, the kinetic energy is maximum, while the potential energy will be 0. While at the extreme position, the kinetic energy will be 0, while the potential energy will be maximum. So basically, in general, if I join it, it would be something like this. And over here, it would be something like this. So this is your, this is maximum, right? This is kinetic energy. And this is your potential energy. While the mechanical energy will remain constant. So this is your mechanical energy. As simple as that. Okay, does it make sense? Right? Related to x square as well. So can you see that x square potential energy is smiley face, while your kinetic energy is frowny face, and this comes from a simple plot of x square and minus x square on a graph. Okay, guys. So this is to do with your spring and the graphical representation of energy versus displacement. So this is your displacement.